Now let us discuss this problem. So this problem, so it says a ray of light is incident on a sphere of radius r. So I have a sphere here. So let me make the diagram. So there is a sphere and light ray is incident. So the sphere of this radius r, it is given, and the refractive index of the material of this is mu. This is also given. Now question says a ray of light is incident as shown in the figure. So figure is something like this. So there is a ray of light that is incident. This is the line that is passing through the center of a sphere and horizontal. Now this says this incident ray is parallel to horizontal diameter and the distance between the incident ray and horizontal diameter is b. So this distance is b. This distance is given in the problem. This distance is b. Find the angle of deviation suffered by the ray. So we have to find what is the angle of deviation delta. So in this case, angle of deviation we have to find. So what we will do, so I will see, so this has a different refractive index. Let us assume this is a air. This side also we have air. So you see, this ray will first, because let me make the normal here. This is the normal. Now this ray will bend towards the normal. So this ray will come something like this. So bending towards the normal. Now if I make again the second normal, now this is going away from the normal. So this will bend something like this. So this ray will go, if it is coming, so it will go away from the normal. So away from the normal, this means this should go something like this. So this is the natural direction, so it will go something like this. So this is the wrong one. So this is wrong. So it should go away from the normal. So this is my normal. So this is the natural direction. It should have gone something like this. But it will not follow this path. It will follow different path, that is the more bent towards the away from the normal. In this case towards the normal. So this is the actual path. If there is nothing, so it has bended towards this side. In this case this is the path, it is bended towards this side. Now let us discuss first, if this angle is theta, so let us say this angle is theta or r, you can say. So this angle has to be equals to r, because this is a radius, this is a radius. So if the sides are equal, angle on the base should be equal. So this is r, this also has to be r. So this angle and this angle is r. Now if I apply sine rule at first phase, I can say, let us say this angle is I. So I can apply 1 into sine I is equals to mu times sine r. So this is the first equation. 1 into sine I is equals to mu times sine r. If I apply the sine rule in second phase, so let us say this angle is theta. So I can find this angle basically. Let us say this angle is some theta. So this the angle. So this angle from the normal to the reflected ray. So this angle. Are you getting or not? So I am talking something about this angle. So let us say this angle is theta. Are you getting or not? Do you have any confusion? So this is the normal. This is the refracted ray. So angle between normal and refracted ray is theta. Or you can say I2 if you want, you can call it I2, so that you don't have any confusion. So this angle is I2. So if I apply sine rule here, I will write mu into sine I, sine r is equals to 1 into sine I2. So in this case angle is I2. So this is my second equation. Now you see, if you equate these two equations, you can write, because these things cancels out. So sine I is equals to sine I2. This means I is equals to I2. So now I got a good result. this angle is same as I. Are you getting or not? So this angle is same as I. Now what is the deviation I am interested in? So you see this angle is what? This angle is the deviation angle. If nothing is there, ray will go something like this. So this is the deviation delta 1. So what is this angle? This angle is I, then this angle is I. So this angle is nothing but I minus R. So deviation at first phase delta 1 is equals to I minus R. Are you getting or not? Can I show some in more exaggerated way? Are you getting? You try to understand, you will get this one. So this angle is I. So this angle has to be I. This angle is R. So this angle is, that is delta 1, deviation 1, I minus R. Now here also you can find this is the deviation, delta 2. So delta 2 we can also find. This angle is, so this total angle is I. So this total angle, we have already found this total angle. Or you can say A if you have any confusion. This is O, this is B. So angle AOB is what? So angle AOB is I. Now angle, so let us call this point is C. So angle AOC, that is equals to R. This angle and this angle is equal. So angle AOC is equals to R. Are you getting? Angle AOC is equals to R. So what is this angle? So angle BOC is nothing but I minus R. I minus R. And that is nothing but delta 2. You see here, this angle is, so this angle is I2, that is equals to I. Now this is the deflection angle, so this is my delta 2. And this angle is same as R. So this angle is R. If this angle is R, so this delta 2 is I minus R. So this angle delta 2 is nothing but again this is I minus R. So delta 1 is I minus R. Delta 2 is also I minus R. So what I will have? So total deflection, that is delta 1 plus delta 2. So this is 2 times I minus R. Now sine I you can easily find from here. So sine theta, if I write sine I, so you see sine I and sine R. So if I find sine I, so this angle is what? So if I make a perpendicular here, so let us draw a perpendicular because this length is B. So if I draw a perpendicular here, so this distance is perpendicular, so this distance is B and this distance is R because this is the radius. Now this angle is I, so this angle has to be I because alternate angle. So these two lines are perpendicular, so this angle is I, this angle is also I. Are you getting or not? If this angle is I, then I can write sine I, this is equals to this side divided by radius. Sine I, that is B by capital R. So now I can write sine I, this is equals to B by capital R. Now if I know sine I can find sine R. Sine R is nothing but sine I by mu. You see the first equation. If you see the first equation, sine R is nothing but sine I by mu, that is B by R by mu, that is sine I by mu. Sine I is nothing but sine I by mu. Sine I is nothing but by B by R. So sine I by B by R, so sine I by mu, that is B by R by mu. So sine R is B by R by mu. So now I know sine I, know sine R, I can always find delta. So let us say delta is given by 2, I is nothing but sine inverse B by R and R is nothing but sine inverse B by R into mu. So this is B by R into mu. You can do more mathematics by taking sine inverse A minus sine inverse B, but we are not interested in the mathematics here. So one important point is the angle of incidence and angle of refraction becomes equal. So this is angle of incidence is I and the angle of refraction is also I. This we have proved. So angle of refraction, that is I2, this angle is also I2. So this we have proved using the Snell's law. And once this is proved, things are easy because I can use the geometry, that is this height divided by this height. So B by R, that will give you sin I. And if you use all the things, you will find this given result. So deflection in this case is not a tough task. Even if you are not getting, you make the diagram once again and then you will get, if you have some confusion. So you have to think something like this: first time, second refraction, and then this side again it will go something like this. If it has gone something like this, so this is the delta 1 I am calling. If it has gone something like this, this is the thing I am calling delta 2. Now here I have the center, and this is my normal, this is my normal. So this angle is I, and this angle is also I. If this angle is R, this angle is R. So this total angle is R. If this total angle is R, so this angle is nothing but I minus R. If this angle is I, so this total angle is I, so this angle is nothing but I minus R. So total deflection delta is 2 times I minus R. Are you getting or not? So this is the only point. We'll discuss the next problem. So this is something related to deflection. If the surface is curved, we have discussed deflection in a prism. If the surface is prism kind, we will have a deflection. If surface is again curved, we will have another kind of deflection. If surface is flat, you will have a glass slab. In that case, we have a lateral deflection. We have derived one result for lateral. So basically, you have to remember all these results. You have to remember the lateral deflection. You have to also remember apparent shift. You have to also remember what will happen if rays goes along a curved surface. Even if you don't remember the result in this case, but you still remember how you proceed. You remember one thing: angle of incidence I at first surface becomes equals to angle of refraction at the second surface. This is always true, because what from where we are getting, until unless this side refractive index and this side refractive index is same, I will always have this angle is I and this angle is also I. So angle of incidence from both sides will be I, until unless both sides refractive index is same. If the refractive index changes, then I1 and I2 will be changing. So this angle is, this side I1 is I, this side I2 is I. So I can say I1 is I and I2 is also I if the refractive index both sides is same. So I1 will be equals to I2, and that both is equals to I. We will discuss the next problem. This is pretty easy problem. So this is the mainly concept of rainbow also. Even if you have, we have worked one problem of rainbow in which we do the delta differentiation of total deflection has to be 0 with respect to a given θ1. So that point we have discussed. So this is the idea of rainbow. We will discuss the next problem.